Welcome to the Chapter 5.3 lesson video. Today we're going to be talking about two different types of parent graphs that we're going to start this chapter on. I know we're not starting at the beginning of the chapter. We're going to kind of jump around this chapter. But with 5.3, we're going to talk about graphing exponentials and logs. All right, so there's going to be two types of parent graphs today. These are pretty new, pretty different types of parent graphs. They're not quite as simple as our other ones. So I would make sure you take really good notes, pay really close attention, so that way you are prepared for class. Let's go ahead and get started. All right, today we're going to learn how to graph and transform these exponential and log functions. Let's go ahead and get started. So first things first, we're going to talk about the exponential. And I think this one is the harder of the two. There is kind of a particular order that I'm going to teach you guys to do things in, and I really encourage you to follow this order. It's going to help you do this correctly each and every time. It's kind of a 4-step process for graphing these. You'll see down here, this is what the graph looks like. There's kind of a couple key features, more key features than some of our other graphs. It has an asymptote. All right, so an asymptote's a dashed line. It's kind of like a force field. This orange line will never go below this dashed line, or if it was on the other side, it would never go above. It's kind of like a force field that we can't cross. There's also a critical point. One unique feature is our critical point is always going to be 1 unit either above or 1 unit below that asymptote. So our critical point in this case is 0, 1, and that's really different than a lot of our other graphs. We normally have 0, 0. Here, our critical point is 0, 1, because our asymptote is at 0, so it has to be 1 above that for 0, 1. And that's probably the trickiest part. A lot of people are going to kind of struggle with that. They're going to try and shift up or down, and they're going to put it in the wrong place because they're going to forget the asymptote is at 0, and then that point is either 1 above or 1 below. And we'll talk about how to figure out whether it's above or below. To get the y-intercept, if you want, if it's convenient, you're going to plug in 0, just like all our other parent graphs. Same idea. All right, so I'm going to talk about these. I'm going to talk about them in the order in which I usually worry about them. The order in which I usually look at the equation, I look for the things that I'm going to worry about. There's 4 key pieces. All right. So the first piece is K. The K is the first piece that we're going to worry about, and that is our up and down shift. So an up and down shift, and a positive K value is going to send you up, and a negative K value is going to send you down. But this is not the up and down shift of our critical point. This is the up and down shift of the asymptote, right? So that dashed line, that's the first thing you're going to plot every time, and you're going to control that with the up and down shift. So be very careful about that. That is what you're shifting up and down. So if it says +2, then this dashed line will move up 2. If it says -3, the dashed line will move down 3. But that's the first thing you're going to look at and you're going to mark on your graph. The next thing that I worry about, and this is going to seem a little weird, strange maybe, is I'm going to worry about my left and right shift. Okay, so the left and right shift, it's like a lot of our other graphs, since it's up and in parentheses, it's kind of an opposite thing. So minus h values will move us to the right, and plus h values will move us to the left. And this is the left and right shift of the critical point. Okay, so the next thing we're going to worry about is the left and right shift of the critical point. We're not going to plot the critical point quite yet. What we're going to do is we're just going to make the mark on the x-axis. So if it was like right 3, I'd put a mark on my x-axis, right 3, just so I remember that. But the next thing I'll do is mark my critical point. Okay, the next thing I will do, one thing I want to point out about that, make sure that up in your exponent up here, this is what I call an exponential graph, is because the x is in the exponent. Up in the exponent up here, if there is a common factor or a negative in front of the x, make sure you pull it out and rewrite this in parentheses. It's a really important step. We'll see an example like that. But if there's a negative in front, or like a 2x plus 4, make sure you pull the common factor out. Okay, the next thing we're going to look at is the green piece. The green piece, this is our A value. Our A value tells us whether we are 1 above or 1 below. Okay, so what I mean by this is if I have a positive A value, then my critical point will always be the left and right shift, but then 1 above my asymptote. If I have a negative A value, then it's the same idea. It's my left and right shift, and then 1 below wherever we put that asymptote. So if the asymptote was up 5, then we'd be 1 below it at 4. If it was down 3, we'd be 1 below it at -4. So it's whatever the asymptote is, you're either going to be, if it's positive a value down here, you're either going to be 1 above, or negative a value, you're going to be 1 below it. And this is going to take some practice because the critical point kind of depends on the asymptote. Okay, so you'll find that asymptote first, left, right shift, and then you'll go to that left, right shift, and you're either going to go 1 above or 1 below. It's always 1 above or 1 below. It's a really important thing. I'd maybe put a star next to that if you're taking some good notes. Okay, the last piece up top, this is our B value. Our B value, it's going to tell us whether the curve is going towards the asymptote or away from the asymptote. So if it is a positive B value, then wherever our asymptote is, we are going to be going away. So if we're on top, we're going to go away like that. Or if we're on bottom, we're going to go away like that. So that's going away. It starts close and it travels away from the asymptote. Whereas if it's a negative B value, and here's our asymptote, we're going to travel towards. So we're going to start far away and then flatten out and get close. So if it's on top, it'd look like that. Or if it's on bottom, it'd look like that. And once again, the way we know which one it is, top or bottom, is based on our A value. So that's why there's kind of like a, I want to say, order of operations here. Asymptote first to figure out where your graph is at. Left, right shift to figure where your critical point is, moving left or right. 1 above, 1 or below. You already know where the asymptote is, so now you just go 1 above or 1 below it. And then through that point, you can kind of see how it happens kind of right at the elbow of the graph. Through that point, you're either going to go flat and then shoot off up away from the graph, or you're going to start far away and then hit that point and flatten out. And all the graphs kind of follow the same thing. So there's kind of 4 steps here. All right, and so I would really kind of think about it in this way. We have step 1, step 2, step 3, and finally step 4 is actually drawing the graph. And if you do it in kind of that order, I'll write this out. I'll get on the next slide when we actually do this. It's really going to help you kind of always do this in a very procedural way that'll help you get the problems done correctly. Let's go ahead and give it a try. All right, so here's one to try. Y equals 10 to the x plus 2 minus 4. Okay, so we got a little bit of stuff going on here, and let's go ahead and give it a try. So our 4 steps, I'm just going to rewrite them out here. This one kind of last time I write them out, and then I'll just kind of talk them through. The first one is find the asymptote. Okay, so find the asymptote. The second step will be to find your left-right shift. Okay, so that's the second thing you're going to do is mark your left-right shift on your graph. You don't actually plot a point at this point. You just kind of mark it on the axes. Your third step is either 1 above or 1 below. Depends, okay? So you look at the graph, you look at the values there, and or the equation, you decide if it's 1 above or 1 below. And then last but not least, you're going to actually draw your curve, and you're either going to go towards or away. Okay, so each graph kind of has a different thing that helps you to determine this. Your asymptote, we said, was based on the K value. The left-right shift is based on your H value. Your 1 above, 1 below is based on your A value. And your towards or away is based on the B value. You can always look back at that other part of this video if you want to refresh on where those are for each of these. So I'll go ahead and I'll start drawing my graph. So I'm going to start by drawing the axes. All right, so I'll draw my nice axes. All right, and the first thing I'm going to do is I'm going to draw in my asymptote. Right, so I look at this value on the end, -4, that is my asymptote. So I'll put a mark on the y-axis. I'll say this is -4. And I'm going to go ahead and I'm going to draw my asymptote right there. It's the very first thing I do every time I do one of these exponentials is asymptote first. Okay, then I'm going to worry about my left-right shift. So I look up here in the exponent, and this is kind of maybe a pre-step. So let me write this up here, pre-step. Check for GCF. Okay, it's kind of a pre-step. I should have done that earlier. There is no GCF. I don't have to worry about it. All right, there's no coefficient in front of the x. So this is just my left-right shift. So my left-right shift plus 2, but remember, that's kind of in a parentheses up there. So we kind of think of that as a left 2. It's kind of opposite for our left-right shifts on most graphs. All right, so we're going to go left 2. We're going to mark it -2. We're not actually putting a point. We're just saying that's where it will be when we plot it in a second. Okay, then we're going to look at our a value. We're going to look at this number down in front. This number down in front is positive, so my point is going to go one above that. So negative, or one above my asymptote. So one above my asymptote is -4 is -3. Okay, so we know one above is just a change of one. Okay, so we now have the kind of the intersection of our points. So we can plot our points here, and we can plot them at -2, -3. And then the last thing we're going to do is we're going to look up in the exponent again, and we're going to say, all right, the coefficient, the front value in front of the x, there's nothing there, but if there's nothing there, it's a +1. So since it's a +1, we're going away from the graph, okay? So we're going to start really close to the graph. We're going to start flat. We're going to hit that point, and then we're going to exponentially go away. Now, I'm not worrying about the y-intercept. I know it's in there somewhere. I'm not really thinking about that. If you really want to do that, it's something you're welcome to do. But these are the 4 steps you're going to do to get a nice graph like this. Yes, you have to do them in this order. It is kind of an important piece of doing these problems. All right, I have 2 more examples here. I'm going to go through them pretty quick. If you want to watch this section again, feel free to rewind as you are going. So first things first, I'll draw my axes. My asymptote is -3. So I'll go -3. I'll go ahead and put my dashed line there. All right, I will go ahead and I will look and see there is no left-right shift on this one, so I will not draw anything else. Down in front, I have a -5, so that means I'm going to be below my asymptote. So I'm going to go down this time, so that's -4. All right, so that is where my point goes. There was no left-right shift, and I'm 1 below, so there's my point. And then once again, I will look up in the numerator, and there is a nothing there, so it's a +1. So I'm going to start close to the line. This time I'm on bottom, though, so it's going to look a little different. So I'm going to start close to the line. I'll hit that point, and I'll go away. I'll just kind of fit it the best I can in there. All right, so the next graph is a little bit different, and there is something important here that I kind of forgot on the last one. The first thing I'm supposed to do is I'm supposed to look at the exponent. There is a coefficient in front of the x. I should factor that negative out, so I'm going to rewrite this. This is a very essential step, and something people are tending to struggle with a lot last semester. Do not forget it. So pull out that negative. It becomes an x plus 4. Please make sure you make a little note of that in your notes. Pay very close attention to it. All right, so that's 3 to the -x plus 4, because that's going to change our left-right shift here in a second. All right, we'll draw our axes. Okay, so I've got to draw my asymptote first, so that's up 2. So I'll go up 2. I'll go ahead and I'll put my dashed line. Dash, 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 dash. All right, then I have to worry about my left-right shift. Remember, I pulled that negative out, so it's a little bit different now. So what plus 4 equals 0? That has to be a -4. So my left-right shift is -4. Okay, so right, it's a +4, so we really went left 4. And then I look down in front, it's a +3. Okay, since it's positive, I'm going to go 1 above. So 1 above 2 is 3. Not because it's a 3, but because it was positive, it's 1 above. So my critical point will go at the intersection of those two. So 3, -4, that's my intersection point. And then last thing I do is I look up, and I did pull out that negative. So I have a negative coefficient. So this time, rather than starting flat and going away, it's going to start farther away, hit this point, and then flatten out as we hit the asymptote. I'll go ahead and try that one more time. I messed up and it erased it. So there we go. That looks good. So it starts farther away and it flattens out as it hits the dashed line. So those are 4 steps you kind of follow every time, and it's really, really helpful. If you did not write it down the first time, I would make sure you go back, write that down on a sticky note, keep it close by as we are doing these problems. All right. One last type of parent graph, and this one's a little easier. We keep this one a little bit simpler. We know exponential has enough to worry about. So this one, they generally all look the same. We keep it really simple. It's a log graph, and as you know from our other lesson that we talked about, logs are the inverses of exponentials, meaning they kind of undo each other. And we'll talk a little bit later about inverses, and you talked about it in math too, I believe, a little bit. But inverses, when you graph them, they kind of have this diagonal symmetry to them, right? Our log graph kind of looked like that, our exponential graph looked like that. Our log graph, it's going to kind of have this diagonal symmetry to it. And we're just going to keep things a little bit simple. For our log graphs, we will only have to worry about left-right shifts and up-down shifts. Now, be careful here. Our left-right shift this time, since we kind of reflected this diagonally, our left-right shift controls our asymptote. Okay, so our asymptote is our first step here. So this time we'll do this one as our first step and this one as our second step. This is the left-right of the asymptote. Okay, left-right of the asymptote, and it is kind of the opposite thing. Minus h sends us to the right, plus h sends us to the left. That's our left-right of our asymptote. And then our critical point is always 1 to the right for these problems. Critical point, 1 to the right. Okay, that's just something we're keeping it a little simpler. If you get into higher level maths, there is ways to reflect them across, but we're going to keep it really simple. And we're just always going to have our critical point be 1 to the right. Okay, so you'll never have to worry about that. There's no flipping, there's no A, no B here. So our critical point's always 1 to the right. So you plot the asymptote, dashed line, and then 1 to the right. And then your K value, that's our up and down. So that'll move this blue point right here up and down. Okay, so our K value moves our up and down movement, positive K for up and negative K for down, and that's of the critical point. Okay, so that's the up-down movement of our critical point. So you'll kind of look at this log graph. It looks a lot like the exponential graph, but kind of on its side. We have our critical point. It's always going to be 1 to the right of this dashed line. The dashed line will move side to side. The critical point can also move up and down, and that just kind of slides the orange line up and down. Otherwise, when we draw this one, it'll always start low and close, hit the point, and go away. And that's just out of convenience for ourselves. You're welcome to do the y-intercept if there is one or if it's convenient, but there isn't always one, so I sometimes just ignore that for convenience sake. All right, let's do a couple examples. All right, so like I said, this one tends to be a little easier, a little more straightforward. I don't worry about writing out steps or anything like that. So let's go ahead and just look at it. So first of all, we have this x minus 5. As always, if there was a common factor in front of the x or like a negative in there or something, you would pull it out so that way you get the correct shift. Minus 5 means we are going to go to the right 5, so go to the right 5. This is my asymptote. Be careful, this is not the critical point, this is the dashed line. Our critical point is always 1 more to the right. So I'll make a mark for 6. I'll look on the outside. There is no up and down, so it'll be on the x-axis this time. I'll go ahead and put my point there. I start low and close. I go up, I hit that point, and go off to the right. All of our graphs for logs, all of our graphs for exponentials, they'll flip around, up, down, increasing, decreasing. But all the ones for the logs are going to kind of look the same. They're going to move left and right with the asymptote, and then they'll start low and close, hit the point, go off to the right. Okay, we keep it simple for the logs. All right, one last parent graph here, or two last examples of the parent graph here for logs. One thing that I want you guys to know, when it comes to logs, any log, no matter the base, is going to be graphed the same. Kind of like with our exponentials, it didn't really matter what the base was. It was a 3, a 7, doesn't really matter. We still graph them the same, whether it's a log base 10 or a log base 7, or this is something called the natural log, which we'll talk a little bit about later. It's always going to be graphed the same way. So I'll do these ones pretty quick so I don't make the video too long. Draw our axes over here. All right, first thing we wrote is left-right shift. And this one, there is no left-right shift. So our asymptote just goes right on the y-axis. So we go right down the y-axis like that. We're always 1 to the right. So I'll put a point to the right at 1. And then I have this -4, so I'm going to go down to -4. And I'll go ahead and I'll put my point there. I start low and close, hit that point, and go off to the right. The next one, very similar idea. It's a log again. ln, just a special type of log we'll talk about later. +3 means I'm going to go left 3, so that's -3. Remember, be careful, this is the asymptote, so you draw the asymptote there. For the log graph, always 1 to the right. So you go 1 to the right, that would be -2. Up-down shift here is 1, so you go up 1, and that's where our point is, -2, 1. Start low and close, hit that point, and go off to the right. All right, with that, you should be able to get started. If you have any questions, please reach out. Start the homework, attempt it, look at it, try it before our next live session. Be ready to ask questions. Hopefully you took some good notes and you are ready to go. Otherwise, I will see you next time, and I hope you have a great day.